You will be learning now how to build a full and interactive object detection software from scratch. For example, if I click the button person that we have right here, you see it starts detecting the person. We can enable another button, for example, remote, and we see also the remote control detected. Hi, welcome to this crash course to build your own object detection software from scratch. My name is Sergio, I'm a computer vision developer and consultant, and I help companies, freelancers, and students to easily and efficiently build computer vision projects. Today, you will be learning how to build a software from scratch where we will be detecting different objects in real time, not only the one that you saw in the preview, but also other objects, and you will find that on the way while you are learning. But also, we will see how to take the Python code and to convert it into an X file so that you can run this on any Windows machine without any installation. So, if you're ready, let's go. To follow along, you need to have Python. It doesn't really matter the version as long as it's one of the latest ones. For example, now at this moment, when I'm recording the video, it is Python 3.10. If you have 3.9, 3.7, 3.8, everything it's fine. So don't worry about Python version. Just you need Python. Then you need the Opencv library, which you can install from the command prompt. So we press start, or better on the search bar, we type cmd. On cmd, on the command prompt, we can execute the commands. So right here, once you have Python, you are able to install the library with the pip command. Pip install opencv-contrib-python. And then you press enter. In my case, I have already the library, so it says requirements already satisfied. If you don't have them, it will take just a few minutes to complete the installation. Once the installation is complete, we can move to the terminal of Python and let's write the code. The first step will be to take the frame or an image if we want to do that from an image, but we're going to do this in real time. So we take the frame from the webcam. Then on the frame, we can do all our detection and then we can move further with the project. So we start with, first of all, importing the Opencv library, import cv2. So this is the first step. Then how do we get the frame from the webcam? We need to create a capture object, which is going to initialize the webcam. It seems hard in words, but it's very simple. We say cap equals cv2.video capture. And then between parentheses, we need to put an index, either 0, 1, 2, and so on. This is simply say 0 is taking the first webcam, 1 the second webcam, 2 the third webcam, and so on. If you have only one webcam, you just go with 0, or if you have multiple webcams, you can try and see which one you're loading. So I will go just with the first one. Then let's get the frame from this. We get ret, then frame cap.read. Now, why do we get ret and frame? So frame is the frame. Ret is saying there is frame true, there is no frame false. This can happen because sometimes there is some error getting the frames from the webcam, so you can get an empty frame, so it's no. If you have a video, at some point the video is going to end, so the ret will say there are no more frames, so that you can choose what to do when there are no more frames. Now let's show this frame. cv2.imShow frame. So this is the name of the window. You can call this whatever you want. So I will just call that frame. And then what do we want to show? Here we need to copy the exact same name. So we're going to show the frame that we just loaded from the webcam. Once we have this, we can theoretically run the code, but you will see it is going to take the frame from the webcam and then it is going to close itself very fast. So you saw Windows and then it closed really fast. And the reason for this is very simple. Once we execute this code, we're going to see what are the other lines and execute the other lines. As there are no other lines, the code finishes and the program closes. So in this case, we need a wait key event so that it keeps the frame on hold. And so we can say cv2.wait key 0. 0 is to freeze the frame. And later we will see also how to change the values and also why to change them. So let's run this one. And now I'm loading the frame from another webcam. So this is now the result. We're just getting a frame, nothing else. This is an image. What is the second step? Considering that we want to have this in real time and not only from an image, we don't need only one frame, but we need to get as many frames as possible in real time. So let's close this one. You should have at least some Python basics to follow this one because it will help you tremendously with this crash course. But the principle is that we put the cap read inside a loop. So the loop is when we finish taking one frame, then we go to the next frame and we show this in a loop, so it's in real time. While true, and then we put everything right here in a loop. Let's now press run and let's see what we get. It's in a loop, but still the frame is freezing. That's for the reason why, because we put CV2.waitKey 0. It means that it's waiting for us to press a key. So each time I press a key, we're grabbing a new frame from the camera. You can hear the sound I'm pressing a key. When I press a key, we have a new frame. There is a quick fix for this. We can say instead of CV2.waitKey 0, we can say CV2.waitKey 1, and we run this one, so it's not freezing the frame anymore, but it's waiting 1 millisecond between each frame. So now you can see that in real time we're getting also the frames just by using Opencv with Python. So far it's very simple. Let's now do object detection by using deep learning. So deep learning is the best method to detect any object. And I'm going to use now a very light model so that we can detect easily 80 different objects on any machine. I will not go into depth about this on this specific course because there will be a lot to cover. So if you want to know more about this, I recommend to watch the object detection video course that you can find on pysource.com. Now let's initialize the model with net. So we have Opencv DNN net. So we're going to initialize the network with cv2.dnn.readnet. On readnet, we need two files. One is the configuration of the model, and then the weights file of the model, which is the file that is trained on thousands of images depending on the object. So it's the actual file that can detect the different objects. And I'm going to put the link to download these two files on the description, but I'm going also to show you the link right here. I created a very short link so that this will be very easy. So pysource.com/download/crash course ods.zip, so crash course with the finally, and then we press enter. And it will ask you to download a file. If you don't see this, if you get any error, make sure that you take the link from the description below so you're sure to download the correct file. This is a zip file which is containing the model. So we're going to save this one. So let's save the file. And then let's open this zip file. Let's open this zip file, and there is DNN model. So we should take this folder and put this folder together with our Python files. So in my case, I have only the main file. This is where the file that I'm writing right now. So main.py is this code that you see right here. On main.py, we're going to put what we're going to put. We will put from DNN model. So we take DNN model from the zip folder that we've just downloaded, and we put this on main. So there is main and then DNN model. And here we have three more files. We have the weights, as I told you, the configuration file, and also we have a text file. We will see why we have that later. So let's now load these two files. First, we need to load the weights. So DNN model /weights, YOLO v4 tiny.weights. So this is the path. Let me show we have main, then we have DNN model on the same folder, then we load YOLO v4 tiny weights, and then we load the configuration DNN model YOLO v4 tiny.cfg. How do we make sure that we're loading them correctly? Well, there is no better way than to run the code. If we don't get any error, we are sure that we're loading them correctly. So now we should see getting the frame from the camera. We see that. So far, everything is good. Now, we have the file loaded. In case you get any error, make sure that the path is correct. For example, if let's say that I don't put this, I don't put the correct path, so I just skip the folder. That's what I get. Opencv, failed to parse net parameter file, and yet it says also which one gave you the error. So make sure that the path is correct, then we can move further. Once we initialize the network, also we need now to define a model. This is an object detection model, so let's define model equals cv2.dnn detection model. Now each model is different. Now we're using YOLO. If we had other models like MobileNet or other models, different versions of YOLO also, we will have different parameters. So in this case we say model.set input params, and we need to pass two specific parameters. One is size equals, let's say 320 by 320. Why this? Because when we process with deep learning, even a 4K frame or like a very big image, the deep learning network doesn't process the bigger the image with its size, but it's going to shrink the image. Doesn't matter the shape of the image, even if it's a rectangle, 69 resolution, 69 proportion, it doesn't matter. It's going to resize that into a square, usually very small square from like in this case 320 by 320 to can be 1024 by 1024. And it's important that there are multiple of 32. So in this case, we can use 320 or we can change the size later. Bigger size, it means better precision on the detection, but also slower on the detection. So we need to find the good balance between them. So like the sweet spot, we have a good detection, but also a good speed. Then we have scale is 1 divided 255. We have this because in Opencv, the pixels go from 0 to 255, while on the deep learning neural network, the value go from 0 to 1. So we need to scale them in order to be processed by the neural network. So this is mostly a very technical thing that is happening on the back, which you shouldn't care about, but it's good that you know why we are scaling them. Scaling is about the pixels value from 255 from 0 to 1. Now we have the model. So we have pretty much everything that we need to perform the detection. So what do? Once we have the model to perform the detection, the second step will be to actually detect what we have on the image. So here we load at the beginning the neural network, then we initialize the camera. Then we get the frames. Let's put a comment so it's more organized, get frames. And now we have object detection. Right here. Object detection. How do we do the object detection? We have the model, so we say model, which is exactly the same that we initialized before, dot detect. Where do we want to detect the objects? Of course, we want to detect the objects on the frame. So this is the frame rate here. And what do we get in exchange? So when we detect an object, what do we usually get as information? There are three things that we get. We get the class, which means the category to what the object belongs to. So if it depends on how it's structured, but in this case it's class 0, it means that that's a person. Class 1, it's a bicycle. Class 2 is a car. Probably not exactly this, but each class is a different object. So we have class IDs. Is the first information that we get. Then we get the score, and then we get the bounding boxes, B boxes. Actually, I'm not really sure if we're getting them in this order, but that's what we get. I need to check to make sure that the order is correct. We will see that right now. So the bounding boxes is for that specific object where the object is located. So we have a rectangle surrounding the object. So we get mostly two coordinates. We get the top left point, and then we get the width and the height of that object. And then the score, how confident is the algorithm about the detection. So if we are 100% sure that it's a person, it will be confidence 1. If we are 20% sure that it's a person, so it will be confidence 0.2. Now, let's see all of them. Let's print class IDs, and then class IDs, so that I can prove you what I am saying. So we have score, it's plural because we have multiple objects, so it's not only score, but it's scores. Then print bounding boxes, and then B boxes. So when we load the model, also we need to pass the networks. Let's see now how this will run, and if everything is written correctly, no typos, we should see the printing. Okay, that's what I wanted. So now I'm going to stop this one. Considering we have frame after frame, of course, we have this printing in a loop. We have class IDs, we have 0, then we have scores 0.7 something, then bounding boxes, and then we have the values. This is already some good information, which is a good start, because if we're getting them, it means that the code is correct, but now we need to use them. So how do we use them? We are going to show them in real time. By showing them, I mean we're going to draw a bounding box, then we can add the text, okay, what is this object, and so on. Considering that these class IDs, scores, and boxes contains multiple objects, we need to loop through them. And now we extract everything. So we have class IDs, we want class ID, so singular one of each of them. Class ID, score, B box, in. This is zip is the function to extract at the same time in a loop multiple arrays. So we extract class IDs, then scores, then B boxes, and let's start now with the simplest and most important one. Let's draw a bounding box around what is detected. So we can do that easily. Okay, bounding box, I show you before what we were having on bounding box. So we have 4 values, x, y, width and height equals B box, like this. So these are coordinates. Let's now, so I will quickly print x, y, width and height, and then if everything is working correctly, we will then draw them on the screen, so to represent the bounding box. So it's working. So we have this, we have the values, so these bounding boxes, and this is the values separated that I was printing, x, y, width and height. Let's use them. We will use them to draw a rectangle. cv2.rectangle. To draw a rectangle, we need a few parameters. We will see them one by one. First, where do we want to draw the rectangle? We want to draw the rectangle on the frame. So most likely everything will be done on the frame that we have. So we get the frame, and then on the same frame we draw the rectangle. Now point 1, the point 1 is the top left point. Point 1 will be x and y. And then we need a second point. So we need top left and right bottom. Top left, we have it. Right bottom, we don't have it because we have only top left, and then we have width and height. From the top left plus the width and the height, we get to the right bottom. So we have x plus width, and then we have y plus h, and we have the second point. Now we can choose a color of our rectangle. A color is made by three values. We have the blue, green, and red. How much of blue do we want from 0 to 255? Let's say 200. How much green do we want? Let's say 0. How much red? Let's say 50. So of course the mixture of the three primary colors will give us any color that we want. Thickness of the rectangle, let's say 2 or let's say 3, so the rectangle will be really thick and very well visible. That's everything that we need for the rectangle. So let's now run the rectangle. Let's now run the code and let's see our detection. Okay, now we see we are detecting a person, which is me. And that's already a good start. So we have object detection in this case. We have person. Now we want also, what else do we need? So this is only a basic starting of our program, but that is much more to it. I will go now and write, what are we detecting? So how do we know if we're detecting a person? Let's see now if it can pick the mobile phone. So it's not the best detection so far, but we will prove that later. Don't worry about improving detection. So now we're detecting two objects, person and mobile phone, but we're not saying anything specific about them. So we need also to tell, okay, what that object is. So let's do that. In order to say what objects we are using, we need to load the classes. And the classes are together with the file I made you download. So do you remember before I made you download three files? One file which extracted was three files. The NN model inside we had YOLOV for tiny weights, YOLOV for tiny CFG, and then we have classes.txt. These classes contains a list of all the objects that our deep learning model can detect. So in order, we start from the class 0. The first is person. So if we detect class 0 is person, the second is bicycle, car, and so on. So if you want to know what your model can detect, just open this file, check the list, and you will see what this can detect. Just for your information, this is Coco dataset. So Coco dataset is a dataset which contains, should be around 120,000, 150,000. It's a lot of images with all these objects, and the model was created from these images. So this is just for information if you were curious how this was created. Now we have the list. Okay, of course we don't have to go and look the list. The model, the code should tell us what is that object. So we need to proceed with this. In order to get that, we have class ID. Class ID will be for, let's show now class ID. We show the class ID cv2.put text. Let's put the text where? On the frame. Of course, everything will be on the frame. Now, what text do we want to show? Let's show class ID. String, because class ID is a number while we want to show a text, and the text must be a string. So we convert class ID to string with str and then class ID. Then where do we want to place the text? Let's put the text together with the object so that it will follow the objects, because that's what really matters. We have this on X position, and then Y minus, let's say 5, Y minus 5, so that it's together with the object, but it's not overlapping the object on the top left point. So we have X and Y. Let's put the text a bit up somewhere here. Font face, it doesn't really matter right now the font. Let's take any font, hair shape, plain. So this is the font of the text. It doesn't really matter. So at least now, this is something that we can make nicer later. We can choose a font, but now any font that shows us the text will be just fine. Font scale 1, this is the size of the text. Let's use one. Color, let's use the same color that we use for the rectangle also for the text. Thickness of the text, let's say 2. And now we can run this one and let's see what we get. So we should get the object, then some text above each object detected. And that's what we see. We have the square and then we have the object 0. Okay, let's maybe increase the size of this text. Instead of 1, let's say 2. Let's give also maybe some more space, 10 pixels. And let's run this again. Now we have, okay, we have the object detected, then we have 0. If I put the font, if I can, we have 67. So we have 0 and 67. What does represent this 0 and what does represent 67? It's very simple when we have the class txt. So the element 0 is a person. So first element is a person. So 0, person. Somewhere 67, okay, here it starts counting from 1. Well, 67 is the cell phone. So exactly, we have the exact order with the class ID with this list. So if we load this list, then we can easily say, okay, what is this object with this list? Let's do that. Right here, after we load the DNN model, let's load the classes. Load class lists like this way. Classes, at the beginning it's empty because we don't have them yet. Then let's load them with open. Then what do we want to read? We want to read the classes txt file that we have on DNN model. So you have that as well as it was together when you downloaded these files. Open then DNN model / classes.txt R, because we want to read the file as file object. So this is the way to open .txt files with Python. Let's now loop through file objects read line because we have multiple lines. So for class name in file object dot read lines, let's now print this class name so we make sure that we are doing this correctly. So let's run this one. Okay, so I ran this one and then I did stop the code. So we have person. You see that there is a space because after on the text file, when we go on the new line, there is what Python sees as \n. So we need to remove also these spaces and then we can put them on the classes. So our goal is to take all the values from class name and put them into this array. So class name will be equals to class name dot strip, and then let's put this on classes. Classes dot append class name, and let's now print classes. So like, let's say objects list, and let's print them. Let's print classes, and let's run this one. I'm going to quit now. So we have person, bicycle, car, motorbike, aeroplane, bus, train, and so on. So with these few lines, I did nothing more than taking this this text file and put this file into an array. So each value, so we have person, bicycle, it can be easily called. So if we say from classes we want class with value index 0, of course this will be person. We have person right here with index 1, it will be the bicycle, and so on. So as you see this, it is now going to be very simple for you to understand how we can use the class list that we have later. Right now we have the class ID. From the class ID we can get the class name in real time. Class name equals classes, and then on classes we use class ID. And instead of showing class ID, let's show class name right here. Okay, we don't need even string, it's just class name. And let's now run this one. So if everything is working correctly, I mean if there are no typos, now we should see person, which is working very well so far. Then we should see mobile phone, cell phone, which is also detected very well. If you get an error on this specific step, so if you get an error on this line right here, it means that you're using an older version of Opencv. Before the version 4.5.4, this is different. So if you have 4.4.0 or older version, you should use it this way. So you need to put class ID and then also index 0. If you have version 4.5.4 or later, just follow along as I am doing right now. Class name, classes, so we have now the classes. We have also the score. At the moment we don't care about the score. Let's keep this very simple. Maybe we can make some adjustment just at the end when we're working with this. And let's now instead move to the next step. Let's now improve the resolution of the camera. We can also increase the size of the frame processed by the object detection deep learning model so that we can have also better accuracy. So let's do these two things. We will start by increasing the resolution of the camera. Where do we do that? Of course, we do that where we get the camera frame. So of course, on the, well, more than the frame, because we get the frame already after we have initialized the camera. So when we initialize the webcam, we choose the resolution. Cap equals cv2.video capture 0 is the webcam initialized. Then on cap, we can have many settings that we can change, like a lot of settings. We can change the buffer size, we can change the camera resolution, we can change also the exposure of the camera, the autofocus, and all these things that a camera can have. We care only about the size. So cap.set, then cv2 dot capital letter cap underscore, then we have the autocomplete. First of all, let's decide the width. So normally the cameras start from a small resolution of 640 by 480, where the first value is the width. Then we have HD 1280 by 720, 1280 by 720. So let's do that, 1280 by 720. So this is the width. Cap.set cv2.cap prop frame height, and then this is the height, width and height of HD. Of course, you cannot choose the resolution we want, so you cannot just put any number, you will get that. These are standard resolutions that the camera have. HD is 1280 by 720. Then we have full HD. I'm going to put a comment, full HD. HD will be what is full HD? 1920 and by 1080. Then we have 4K, we have 8K, and so on. I recommend to just go with this size, because the more you increase that, the harder it will be for the computer to process the information. Now, how do we make sure that we have the camera resolution correctly set up? Well, let's run this. If the screen now is bigger, it means that we did a good job. If you get an error, it might be that your camera doesn't support this, but mostly, like I'm using now on this example the standard laptop webcam, and you should have this as well. So person, it's working well with person. Let's see with mobile phone, not so good. Let's now also increase the frame processed by the deep learning model. For example, we can check where we have 320 by 320. Let's go with 416 by 416, and let's see how this will run. You might see that this is slower, just slightly slower, because bigger image, usually better resolution, slower processing. It's not always, doesn't mean that if you put the image 2000 by 2000 that you will get a better resolution. Of course, the model has some limits, and we don't improve that. It doesn't improve that much. Cell phone. So let's keep this for the moment by 320. If you're wondering about the precision, and if you think that the precision is not good, this is because this is a very small model, and I'm using this small model because I want that everyone will be able to run this on any computer. You can increase dramatically the accuracy using a 10 times bigger deep learning model. You will see a huge difference on the detection. You will be able to detect with heavier models smaller objects, but for this tutorial the steps will be the same. It will just change the size of the model. So let's stick with this for the moment. Now we have this set it up so far. Let's now make this more interactive. So we're going to add some button that we can click. So if we click person, we will display only person. If we click another object, we display only the other object, and so on. So the idea is that we add a few buttons, we click on that button, and we display that in real time. So let's do that. How do we add buttons? We can create them manually by setting a mouse callback function. Let's do that right here. Let's create a window, create window, and then cv2.named window, and this will be frame. So I'm creating a window because otherwise I cannot associate the mouse click with that window. So when we create a window, it must have the same name of this one. So right here with imshow, we display the frame window. When we want to set up mouse callback, we want to create that window first of all before displaying anything. Then on that window, cv2.set mouse callback. What is the window name? Is frame. Then when we click the mouse, we want to execute some function, and right now is click button. We don't have the function yet, so let's create now the function. We can put this function anywhere. Let's just put it right here. Click def, click button. It will be event, then x, y flags, params. So don't worry about all these. Okay, it's event, not events. Don't worry about all these values. We don't have to do much with them. That's only the way we used to call the mouse functions. So we say if the event is cv2.event l button down. So if we click the left button of the mouse, we can, for example, print X position and Y position. So let's now run these two. So I want to prove you that everything is working correctly, that when I print with the mouse, we get the position. So ideally, we create later a button. So when we click the button, we know that's the button, and everything is working. So we have a lot of output, so it's even hard to see this, but let's maybe hide some of the outputs that we have because we don't need them anymore. So the printing of class IDs boxes, I'm going to comment all this because we don't care about them right now as we're using them already. So instead, let's have a clean output, and only we will see when I click with the button of the mouse, we will see on what position I am clicking. That's the window. The output, if you see right here, the Python output is clean. Now I'm going to click. So we have the click, we have the position, X position and Y position of where I had the mouse. So it's hard for you probably to see it. but let's now click it here. Now we have the mouse on another position, 125, 560, and so on. Ideally, I'm going to put different buttons, and if we see that the button is where the mouse click is, then we can activate that button. Otherwise, we can deactivate that button. So let's do that right now. And we will do this way. So click button, event X and Y. The mouse click concept is very simple because we are going to draw a button. So if the click is inside that specific rectangle, so it means that we are clicking that button or rectangle that we've just created. If not, then we're not clicking it. So very simple. We have here the coordinates where we should look. Is this X and Y inside the button? How do we know? First of all, let's create a button. So how do we create a button? We can go right where we have the code, and it doesn't really matter for the moment where we draw the button. So let's do that just after the detection. So create button. How are we going to create a button? We're going to simply draw a rectangle. Save it to that rectangle. Where are we going to draw the rectangle? Let's draw the rectangle, of course, on the frame because we have only the frame, so that's what we use. The rectangle needs to point. Ideally, we're going to draw a button on somewhere on the top left of the screen, so we draw a few buttons on top of each other. Point 1, let's start from position 2020. So position 2020 is from the top left. Let me explain how the positioning works in Opencv. So if we have, this is the Opencv window, it starts 0, 0 right here, 0, 0. So of course the coordinate is X and Y, so we start, if it's 2020 it will be here, so 20 starting from the left, 20 starting from the top, counting down. If it's the position, a point, 100 and then 20, it will be first value, so 120, 100. Of course, I'm using the mouse now for writing, so it's not the best, but you get the point. So this is 120. We start counting from the left, so 0, 1, 2, 3 until 100 pixels. So this is the first position, and then left to right the first value, then from top to bottom, so from 0, 1, 2 until the position 20. So this, for example, can be the point 120. So let's draw the button somewhere here. So we draw, let's do something like this. We have rectangle, so from point 2020 to point 2020 to 100, let's say 50, 150, and then 70. 150 and 70. What is going to be the color? Let's make this red. 0 of blue, from 0 to 255 we give 0 of blue, 0 of green, and let's make a red not so strong, so from 0 to 255 we give only 200. And now we want to fill the circle, so we say -1. If we give a value, positive value, so for example 2, 3, it will be how thick is the border of the rectangle. If we give -1, there is no border, it's completely filled with the color, the rectangle. So if I run this one, we will see now the result. We have right here the rectangle, the red rectangle. So theoretically we're just drawing a rectangle, but that's how we create the button. The next thing that we can do right here is to put a text. Okay, what do we want to display right here? So if we click there, let's put a text, put text. Where do we want to put the text? On frame, of course. Now the position, we want to put the text somewhere inside the button. This is not intuitive in general because we need to put the coordinates manually. So Opencv is not the best for the graphic. For the user experience, you should use something like PyQt for designing user experience software, but now for simplicity we're going to do it this way. cv2.put text frame. Now what text do we want to put? Let's say person. So Ideally, if we want to detect only person, the person category, we just click there and we activate the person. Then we will add a few other buttons. If we want to detect the other categories, we click the other buttons. We will see that step by step, so don't worry if at the moment it seems hard. It's not. Person 2020. So where do we place the text? For the text, let's say if this is the text person, right here, person. Okay, this is enough. I will not write anymore here. We need to give this point right here, the bottom left of the text. So we give this point and then we draw the text. The bottom left, if this is 2020 and the height is probably 70, I don't remember. The height is 70. So we somewhere here it should be around 30 of the x and the height could be around 60. Let's do that. 30 and 60. Of course, if you have hard time with the coordinates, this requires practice. So you can just draw the rectangle on different positions, put the text on different positions, and it will come natural to you after some trial and error. Now, font face, cv2.font. As before, we don't really care now about the font Herschel plain. Font scale, let's give 3. Color, let's make this white because we have red, so let's make some good, very high contrast white. How do we make the white? The white is all the colors together, so the mixture of the maximum of the 3 primary colors, so 255 will give us white, the opposite will be the black, where is the absence of all the primary colors, so 000 will be black. Thickness of the text will be 3. And let's run this one just to make sure that everything is correct and the positioning is correct. And let's now wait that this runs. Okay, it's running. Okay, the text is quite big and the button is small, but you get the idea. Now, I'm going also to, of course, increase now the rectangle so that person can fit completely inside that. And then we check if we are clicking inside the rectangle. So that's a very important key. Now put text person. Okay, let's increase the rectangle. Instead of 150, let's say 220. So we just make it wider, 220. And then we need to check the click. Okay, how do we know if we are clicking inside the rectangle? Well, we should make somehow match these positions, so the rectangle with these x and y. So we need to check if x and y is inside the rectangle. How do we do this? We have the function cv2.pointPolygon_test. So let's do that. Now it's not probably the best structure, but it's the most intuitive. Let's now take the coordinates of the rectangle, this one. So I'm going to say you it's not the most intuitive. Now we need to convert the rectangle to a polygon because the Opencv function works with a polygon to check if a point is inside that. So let's do that quickly. And this will be also good practice for you. So polygon. How can we draw a polygon which is a rectangle? So we take 4 points. So instead of giving top left, right, bottom, we take top left, top right, bottom right, and bottom left. So a polygon is 2020 is the top left. Then we have 2020, 2020, 20. 2020, 220, 20, 220, 70, and then we have 20, 70. So we have the 4 points which make this rectangle. So 20, 70, and I can prove you that because instead of rectangle, I can say now cv2.fill poly. So we fill a polygon on the frame, What are the points? PTS. Color, let's make these 0 to 0, 200. And then that's it. Okay, because this is field poly. So PTS, it will be polygon, polygon. And I'm going to run this. We will get an error, but I will explain why. So now nothing should change. We're just converting the rectangle to a polygon, and this is a good practice for you. Now we're getting an error. We're getting an error because we are parsing something, the coordinates, in a way that the field poly function doesn't accept them. And this is important to know in computer vision, that when we use coordinates with Opencv, they need to be not simple arrays. So it's about arrays, not simple arrays, but numpy arrays. So let's import numpy as np, np.array, and that's how it should be. Now I'm going to run this, and I will quickly explain why. First, I need to make sure that it runs correctly, that there are no typos, and later I can explain why we're doing this. Okay, let me change this. Okay, also the type of the array must be corrected. Okay, so this must be arrayed inside an array. This is not, of course, the most intuitive function that exists, but that's how it works. And why NumPy? There is a very simple reason, because NumPy is much faster. So NumPy is a library which has Python API, so we can call it with a very simple code, but it's very fast to process the information. While if we use just Python array, Python is a very slow language. And in computer vision, especially when we work in real time, so now we're working frame after frame, it's essential that we have a good speed to process, around 30 frames per second. As you see, now we have person, and it's just a rectangle, but we just converted that instead from this rectangle to a polygon. Now let's take this one. Okay, let's make a copy of this one, polygon, and let's now check one thing. Now when we click the mouse with the left button of the mouse, we're getting X and Y, and now we have also the polygon. In order to make sure that we're clicking inside that button like this, we need to check if is X and Y inside the polygon, and we have is inside, let's call it this way, cv2.point polygon test. How do we check this? We want to check the polygon, and then we have the point X and Y, and then false. We're just going to check if it's inside. If we say true right here, it's measured distance. So if it's outside, it can also tell how far it is from the polygon. We don't care about that. We just want to know is inside or not. So we say false. If is inside is greater than 0, so it means that it's inside. Print, we are clicking inside the button. And let's print also the position X and Y. Let's run this one so I can prove you that it's working. And you can prove it yourself by running the exact same code, or with the adjusting that you want to change. If you want to change anything, of course, you're free to do that. So let's click now. I click outside. We're just printing X and Y, so nothing. If I click inside, we see we're clicking inside button, the position 207,444. So what can we do right now that we know that when we're clicking inside or outside the button, we could create a switch. So we say if we click inside, either we switch it on or off. So let's do it. Let's create a button. Now it's not the most intuitive. Later we're going also to clean the code. So just follow, if it's hard for you, just make some struggle, because trust me, it's worth it. Let's right here define button person is false. Okay, we're clicking inside the button. So we want to activate the button if it's not activated, and we want to deactivate the button if it's activated. So it's a toggle button. If it's inside, so if button person is false, button person equals true. And if button person, no, okay, let's say else button person is false. Button person doesn't exist right here because we need to bring this inside the function. To bring this inside the function, we can just define global button person, and let's print now button person is, and we say if active or not active, button person, so true or false. And let's now run this one. Let's see how this works. Okay, now we click person. Now button person is true. Now we click person. Now is false. We click again. Now is true. Let's now understand how to make a condition what to show on the screen. So now we are detecting person anyway. If we click the button, nothing is happening because we are not doing anything with the button. But we want to understand how to do that. So let's go on the code, and this will be very simple because we have class name right here, and each time we detect the class, print class name, we know exactly what we are detecting each time, among the list, of course. So let's run and let's see what we get. So of course, on each frame there is person. So if I put some other object, let's see if it can get this one, cell phone, we see also cell phone somewhere right here. We can choose what to display. We can say, for example, if class name is person is, or not is, sorry, it's equals to person, then we can display person. So right now we are making an if, we are putting an if condition on the class name. So only if we have person, the bounding box will be displayed. So now if I show the phone, for example, there is no way that this is going to be detected as a cell phone because we have only the condition for class name person. So if I say, for example, if class name is cell phone, of course I'm not going to be detected because now there is the condition for the cell phone. So let's see, I'm going to preview that. So now there is no bounding box, but if I put the cell phone, you see now we have cell phone. And now let's use the class name, but let's also use the switch button. So if class name is person, and what is the second condition? So we want to make sure that the class name person, but also that the person button is activated. And button person is true, then we display that. So now we have some potential. So now that the program is interactive because we can click the mouse to activate or deactivate in real time the detection of person. Now by default person is not activated. Now if I click anywhere on the screen, so I'm clicking, you see we have the coordinates where I'm clicking, nothing happens. If I click on person right now button person is true, is activated, and we are detecting, so we have the bounding box around the person. If I click again, we deactivate that. If we click again, we activate that. We can add many buttons for as many objects as you want. At least they must be on the list, at least for this small project. Of course, you can create your own custom detector. I have that one. It's more advanced. Of course, I can't cover that. I have that on the course how to create a custom on the object detection full course on pysource.com, how to detect on any object, but right now we have 80 different objects that we can easily detect for this project. Let's now do one thing. Let's add more buttons. But now I know that this seems very hard and not intuitive. I just made these buttons from scratch to show you how you can easily find a way to create things from very basic functions. So we don't have like the button function on Opencv, but we can draw a rectangle, we can draw the text, we can choose if to change the color, what color to put on the text and on the rectangle. So of course, we can create a button and we can create whatever we want on the window because we have a lot of freedom. To make things very simple, and now as I don't want to waste a lot of time on creating a lot of buttons, I've created a library. It's a file which is called GUI-buttons.py, which does that dynamically. So we have the functions to add the button, to display the button, and we can detect when we click the button. So I've created this one that you can download this. So I will give actually this one when you download the DNN model. You will find also GUI-buttons.py. And so we can create the buttons with just around one line of code to create a button and then a couple of lines to just activate the buttons. You will see how great is this file that I've created and how this will make your life easier. So I'm going to remove the buttons that I've created right now because we don't need that. So all the polygon that we have right here, we don't care. So let's just keep the function click button, very simple, from click button to if event and then print x and y. Let's remove this condition right here and let's display now everything. Okay, let's also remove where we have the function create button. Instead, you will need to put the file which is called GUI-buttons.py together on the same folder with the main.py, and we're going to import that. We're going to import from GUI buttons, we are going to import buttons. Now let's initialize buttons. Button equals buttons, and with this library it's more a file than a library itself that I've created it, you can download. We can add a button very easily. Button dot add button. Now what do we want to display? Of course the text must be some of the classes of the list. So from the classes.txt we can choose the object that we want to display. So let me pick person. So we're going to add person right here. Now the position of this. So we need to give only the top left point of this button, let's say 2020, and then the rest is calculated automatically. So 20 and 20, top x, 20x, 20 the y. Now we have already the button, just one line. So it's very simple. You don't have to go through all the hassle that I've just shown you. Instead, now after we created the button, let's now display the button on the screen, because now we have the button, but if I run this one, there is nothing because we are not displaying that on the screen. So we need to take the button and display it on the frame. And of course, to make things very simple for you, I have also created a function for this. Display buttons. Button dot display buttons. Where do we want to display the buttons? On the frame. And anything else? For the moment, let's run this one. And later we can also see how to work with that and how to activate it, deactivate it, and what to do to change the objects that we display. Now we have a button which is called person. Now if I click on this, nothing is going to happen. When we click the mouse, we need a function to make the button activate or deactivate. How do we do that? Right here we say if event is event L button down button dot click button click. Now we need to give where did we click? We click on X position and Y position. X, Y. And now let's run this one. So we should have now at least this activated. Now the button is not activated. Now I'm going to click right here and it's automatic right here that we get when it's activated, it's full color and this is not activated. And you see is false or true. Now how do we get now the list of the buttons and also the classes? So how do we choose here the condition? I have a thing for that, which is get list of the active buttons, because this will work with multiple buttons and we will see that very soon. Get active buttons list, active buttons equals button dot active buttons list. That's all. You don't have to really do much. So we print active buttons, active buttons. Right now we see there is active buttons, it's an empty array. If I click person, we have active button is person. We can add multiple buttons. So we have class name. If class name, before we were checking, if class name is, for example, person, then we can display. Or if class name is banana, we can display that. We can do this normally when we want to do this, but we have when we want to put some condition, but we have a better way. If class name is in the active buttons, so if class name is on the list of the active buttons, we display them, otherwise we don't display them. So let's try person, and you see now person has this violet color. Let's see cell phone. Cell phone is somewhat between red and brown, it seems at least. Keyboard it's similar to cell phone. Then we have remote and scissors. Let's try all of them. So we have now the remote and we have scissors. And then you can try this with the other objects that you have. What you will be now thinking of, and it's one of probably the most important thing, is to deploy the program. So once we have the program which now is ready, let's go and make the program into an executable file so that everyone can run it even if Python is not installed. So this is very easy. You make the program into an X, then you put it on any computer and it will be ready to run without any installation. Let's do that. So before we convert this into an X file, there is an important thing to add regarding closing the window, because now this button doesn't work. If I press any key on the keyboard, it doesn't work. So what we will do is to put on a key event so that we can click any key on the keyboard and we can close this. So on the code, there is the last line, which is cv2.wait key 1. We want key equals cv2.wait key 1. So this one is waiting for us to press a key. If we don't press a key, it goes to the next frame and shows the next frame and so on. If we press a key, we can decide what to do with that key. For example, if the key equals 27, 27 is the S key on the keyboard. In this case, we can quit. So we can break the loop. So if I run this one, now I press the S key and the program stops. There is also another thing that it's good practice to add, and is cap.release. Because we need to release the camera, because if for any reason the Python code is running, even if you're not displaying anything, it will keep the camera on hold, and so if you run the camera on any other software like Skype or Zoom, it will say the camera is used by something else, some other software, Python. So we always need to release the camera, and also let's destroy all windows. cv2.destroy all windows. So we run this one, and now we click ESC, and of course with this code we are more sure, we have a warranty that we're going to release the camera and close everything. Let's now generate an executable file for Windows. This means that your program will be converted from Python to an X file, and you can use this on any computer without any installation, because of course now you need Python, you need a few libraries. When you put everything inside into a package, you can take this to any computer without any installation, and this is great when you want to deploy the software, you want to give the software to people who don't know anything about Python so that they can run and use what you've just built. And this is essential, of course, for commercial projects. So let's do that with Python, and it's very simple because there is a library which will do everything for us. First of all, let's install the library. We go on cmd. So we run the command prompt. This is a Python library, so we can install this with pip install cx_freeze. And the installation of this library is very quick. I have that already installed, so in my case we have requirement already satisfied. Let's now close this one. Once we have the library installed, we need to create a setup file, which is a Python file where we simply give a few instructions about our program. So we put the setup file together where we have the main folder. So let's do that. New Python file setup.py. So where we have the main file, the same folder, we have main file, we have setup, GUI buttons, and we have the DNN model subfolder. What is the setup file about? Here we give a very few lines. Of course, you can personalize this in many ways. This cxfreeze library gives you a lot of options, and I will put the link of cxfreeze on the blog post if you want to know more about X files. For the moment, let's import from cx_freeze, which has capital letters in this case. So keep this in mind, because if you put the lowercase f, you're going to get an error. So cxfreeze uppercase f, we are going to import setup and then executable. Now we write setup, and setup is nothing more now a function where we just give a few instructions. First of all, what is the name of our app? Of course, you choose the name of your app. I will call this object detection software. Let's say simple, because it's very simple. There is nothing advanced about this software. Then version equals 0.1. It doesn't really matter. This is just to have an history of your app. So if you make some update, you can say version 0.2. It's up to you. Like, this is just a text. You can pretty much put whatever you want right here. Then we have description equals, and it's the same with a simple description of our software. This software detects objects in real time. And then executable. So we have executable. Right here we need to put the path where we want our program to appear. And then right here we need to put the main file that we are using where we have our code. So normally with Python I'm running the main.py file. So this is the file that has all our code, our program. So we need to put that one right here on executable. So we'll put main.py. Of course, if your file has a different name, you need to put the exact same name. And now our script is pretty much ready for the setup. Normally we will need to run this from the command line. So I open cmd, and we need to run Python. Then we need to put the setup.py path. So in my case, it's a very long path, so I'm just giving you an idea, and later I will just build it. So if my program was on C, so let's give the path C program, and then setup.py, and then build. That's the program that the line that we need to run. Python C program setup, or of course here you need to put your path. So check the path where you have the file, put right here your path. If your path has some spaces on it, just remember to put the quotation marks before and at the end. So if your path was C program or mine with the space, use the quotation marks and then build, and then you press enter. I'm not going to do that because I have multiple versions of Python installed, so it will run the version that I don't want. So I'm going to use PyCharm. If you have PyCharm, just follow exactly what I am doing. On the setup.py file, we select right here setup, we edit configurations, and we go exactly on parameters. So parameters right here will be built, and then we click apply. So with this change, we are running the program with the argument build. And then we can run this one. So I'm going to run setup. If everything is working correctly, you will see running build and running build X, and it is going to take a few seconds to a few minutes. Keep in mind that this is going to build your Python library into an X file. If you have other libraries installed that are not for this tutorial, this X most likely is going to include all the libraries that you have for Python. So I recommend to start and do this with a clean version of Python, because otherwise it will be a very large X file and you might encounter some errors. Now the building is complete, and we can now check that exactly on the folder where we have our program. So we have setup main, and you will see a new folder which is called build. Inside build, we're going to have X win, and then right here we have our main X file. We're going to run this one. And first of all, it's not running because there is one reason. We have the main file. Let's also put together the DNN model. So I'm going to copy the folder. The folder includes classes, YOLO, tiny, configuration weight. Let's copy this folder and let's put the folder together. So we go on build, then X win AMD64, and then we paste DNN. Right here there is our entire program. So if I run this one, this is the program running real time from the X file. If I take this, so the only thing that I need to take is this one. We take this X folder, we can move it in any computer, even without Python, it will just run. So it's so great and so simple to run anywhere when you do this. And of course, I can prove you that it's working. So we have person, we have cell phone, it's working exactly as it was working before. And on the other side, we have also a window with the output. We can, of course, hide this window. There are some instructions to hide this window right here when we compile with the setup.py. I'm not going, of course, right now into that because it will take a long time and it's not necessary for the purpose of this video. This is all for this crash course, and I'm sure that if you've got to the end, first of all, congratulations if you've got till the end, because most of the people just start with one tutorial and only a very tiny small part get till the end. And with this, for sure, you learned a lot of things regarding basic functions of Opencv, object detection, even if we light tiny YOLO model. And very important, how to prepare a Python file and put it into an executable file for deployment so that you can use this on any computer you want. Let me know what you think about this tutorial and what you would like to see next, because even if I don't always reply, I always read all the comments, and when I see some common topics asked quite often, I usually make either a free video, either I put some more material on my courses and so on. This is all for today. See you on the next one.